Hey, welcome to Pomodoro Joe for Sunday, October 22nd, 2023. Today we're looking at LeetCode problem 1793, maximum score of a good subarray. This is a hard problem. All right, we are given an array of integers, nums, 0 indexed, and an integer k. All right, so we have an array of integers and a number k. The score of a subarray, ij, is defined as min of nums I plus 1, nums j times j minus I plus 1. A good subarray is a subarray where I is less than or equal to k, which is less than or equal to j. Return the maximum possible score of a good subarray. All right, so let's break this down a little bit because I think half the challenge of this problem is understanding what they're asking. So the score of a subarray, ij, so that means the starting index is I and the ending index is j, is defined as the min of the values in this subarray. So basically we have two indices, I and j. The subarray is defined as all the elements between those two indices, including the indices themselves. All right, and the score is the minimum of those numbers times j minus I plus 1, and that is just the number of elements in the array. So we have some subarray that's defined by a start index I and an end index j, and our score is the minimum number or the minimum value of that subarray times the elements in that subarray. Okay, and now we have to have an I that's less than or equal to k, which is less than or equal to j. So since I is our left index and j is our right index, it's saying that our I has to be between 0 and k inclusive, and our end index has to be between k and the end of our array inclusive. So I has to be less than or equal to k, and j has to be greater than or equal to k. So that means k has to be somewhere in our array. So the element at index k is definitely in the array, but we could start somewhere before k, and we can end somewhere after k. All right, so we have an example here. 1, 4, 3, 7, 4, 5, k is 3. So that's 0, 1, 2, 3. So this 7 is our k element. So that element has to be in our array. Now the output here is 15. Let's see how they get that. So we could do 7, 4, and 5. So the min index there is 4, and that's 3 elements. So 4 times 3. So that's 12. Now we could also include this 3. So that's going to give us the new minimum element. So that's 3, and there's 4 elements here. Again, it's 4 times 3. Then we go to 4 here. All right, so this is going to be, our min element is still 3, because we're going to include all of these numbers. But we have 5 elements. So that's 3 times 5 is 15. And if we were to go further to include the 1, our min element would drop down to 1 and be 1 times 6. Okay, so that's how they got 15. All right, so this one doesn't actually seem that bad. So let's put 25 minutes on the Pomodoro timer and get started. So now that we understand the problem a little bit, we know that the element at index k has to be in our subarray, and we can move our start of the subarray anywhere between 0 and this k, and we can move the end of the subarray between k and the end. So let's just start in the middle, or at this k element. Let's set I and j both equal to k. So our subarray starts as one element of the element at index k, and then we'll start moving out from that element. We'll move left and right, so adjusting our I and j's along the way, keeping track of which element is our min element, and keeping track of how many elements we have in our array. Okay, so let's just start with some result here. All right, so we already know that our result has to include k, so we can start our result as nums at index k. Okay, then we have I is equal to k, and we have j is equal to k. And then our min element, we're going to keep track of the min element so far. Maybe I'll call it min val, that's easier. So the min value, again, will just be nums at index k. All right, so this is our very first subarray, just the element at index k. Now we need to go through and adjust our i's and j's until we exhaust all of our possibilities. So while our index I is greater than 0, we're going to be moving I from k down to 0. So how do we know when we're done? Well, we've either reached 0 and we've reached some max index. Okay, so let's keep track of our max index here too. So we have some max index, and that's going to be the length of nums minus 1, since this is a 0 indexed array. All right, so while we still have some I, so I is greater than 0, or we still have some j is less than the max index, then we keep going. So I think the first thing I'll do is calculate our current score. So let's see, our score, well, that's equal to the min index, or no, not min index, min val. I'm glad I called it min val. The score is equal to the minimum value times, and we can just copy what it says here, j minus I plus 1. So let's just do that. J minus I plus 1. So that's our current score. Let's check to see if this is better than our current result. So the result will equal this score if this score is greater than our current result. Otherwise, we're going to keep our current result. All right, we've calculated the score. Now we have to move our I or our j or both. So how do we move these? Well, let's first check. Can we move I? If I is equal to 0, we can't move I. So we'll only move j. So j plus equals 1. And now we need to check. So we've moved our j. Let's check to see if the element here at this new j is our new min element. So let's see, min val will equal, I'm just going to do the min here, min val or this new element. So nums at this index j. All right, so I'm checking. I've moved my j. Is this value smaller than our current smallest value? If it is, it's our new minimum value. All right, and then we can just continue. I'll do that. Okay, so if we can't move I anymore because we've already reached the end of our range that I fits into, then we'll move j. Now if we can't move j anymore, so if j is equal to max index, we can't move j anymore, then we can move I. So I minus equals 1. And our new min value, we'll just do this, I'll just copy this here. But now instead of looking at j, we need to look at the element at index I. And we'll continue. All right, so we've checked two possibilities. We either move I because we've reached the end of j, or we move j because we've reached the end of the range for I. All right, now what are the next options? Well, I really want to only move the one that gives me the best answer. So I can look ahead. Let's look ahead at the next I and the next j and see which one of those gives me a better value. So I want the maximum of our values because I want our minimum value to remain as high as possible. So let's do this. We have some next I. That's going to equal I minus 1. And we have a next j, and that's I plus 1. All right, so we have our next I value, or our next I index, and our next j index. And this should be j plus 1. All right, so our next I will be I minus 1, and our next j will be j plus 1. Now let's compare the values at these two indices to see which one will give us the better answer. So let's see, if nums at next I is less than the nums at next j, well, in that case, I'll move my j value because I want to keep the highest possible min value. So in this case, our nums at the next I is less than the nums at the next j. So let's move j. So that's actually this right here. So I'll just copy this. All right. And now we'll do the same for the opposite. So we'll check. I'll just copy this whole thing. All right. If nums at index j is less than the nums at index I, or next index I. So if the nums at next index j is less than the nums at next I, then we'll move I. So I minus equals 1. And the min value, again, will be the min of our current min value, or this new value at, this should be next j and next I, right? Next j and next I. All right, so now if we make it this far, that must mean that both of our values are the same. The next j and the next I values are the same. So we'll move both. So let's do that. I plus equals 1, no, minus equals 1. And we've already done the calculation. So we can say I is equal to next I, j is equal to next j. And then we'll just calculate our next value. And then our min value can just be the min at, well, either one of these. So, all right, that handles all of these cases. We've got the case where we're at the end for I, at the end for j. I is less than j for the next, or j is less than I for the next one. Otherwise, they're the same, so we advance both and check our new min value, and we return. Okay, so once we do all of these loops, we will end up with one score that we haven't calculated. So we get to the very end and we haven't calculated this score because we've advanced to this point where this conditional is no longer true. So we have to do one more check outside of this loop. So this is our final score to calculate. All right, and then at the very, very end, we can return our result. All right, let's see how this works. All right, seems to work. Let's see if we can pass all the tests. And we pass. And let's see, we do pretty well, actually. We beat 88% for runtime and 93% for memory. So this is actually a really good solution. Now, one thing we could do, I use some of these mins here, min, min, min. We can convert these to our own min calculations, which can sometimes give us a little bit of a boost. So let's see, should we do that? We've got time. Let's give it a shot. All right, so this min, it looks like it's min value. All right, I think that should do it. Let's see. Okay, does this save us anything at all? And it saves us a tiny, tiny bit on runtime. So now we're at 89% for runtime and a 77% for memory. So we trade off a little bit of memory for a little bit of speed. All right, okay. Well, I think that's it for me. If you want, you can check this out. You can jump in here and find out how other people solve this problem. But I think this is a pretty decent solution, pretty straightforward, easy to understand. And this is a hard problem. So for something that's a hard problem, this is a fairly simple solution. All right, well, that's it for me. I hope you enjoyed this. I hope you had fun. I hope you learned something. I hope you can go out and write better code.